base A of x equals y is the same thing, and this symbol right here is if and only if, or a bijection, or in plain old English, you can use the word it means that a to the y is equal to x. Now, if you look at the book, I believe it's the other way around. It says y equals log a of x means x equals a to the y. I think that's what it says in the book. Yeah, see, they have it backwards of what I have. The reason that I write it this way is there's this little curvature motion that really helps me out, and it seemed to help out people in the past. If you take a and raise it to the y, you can get x. You see that little curvature motion that you can make to generate this over here, a to the y equals x, a to the y equals x? It will help you when we have numbers to take the base and raise it to the other side and get the inside number. It's a nice little, I don't know what you call it, it's a nice little method, I suppose. All right, so let me get out this worksheet.
Why is it below the, is that like a denominator, or is it just?
It's called the base. This is the base, so we'll call that one the base. And notice that this a is the same as this a that's in the exponential. So the restrictions that we had on the exponential base, in other words, a has to be greater than 0 and a cannot equal 1, is the same here. It's the same a. I don't know if I have enough of them right now. Maybe I do. The rest of you guys over here, I have more of these. I'm going to have to give you right after class. So you guys take some good notes back here, okay? And then I'm going to put all the problems on the board as I do them, so then I'll give you guys one right after class. I just didn't make enough today, guys. The first 8 problems are just an exercise in transferring back and forth between the log base of a number versus the exponential representation. So these are all true already. It is true that log base 6 of 36 does indeed equal to 2. But to change this back into an exponential, how would I write this? Well, this is where that little motion comes into play. That means that 6 to the second power equals 36. See what I mean by that little motion? 6 squared equals 36, and that is true. Certainly looks a lot truer here than there, though. You might not have believed it here. Not quite used to log. That's number 1. Number 2, I have log base 289 of 17 is equal to 1/2. How would I write this as a log or exponential equation? 289 raised to the good. We'll just do 3 and 4 here. Log base 14 of 1 over 196 equals to -2. So how do I write that as an exponential equation? Yes, it's negative. 14 raised to the what? -2 equals to 1 over 196. And this is true. 14 over -2 is the same thing as 1 over 14 to the positive 2. What is 14 squared? 196. So this works. Number 4. Log base 3 of 81 is equal to 4. What does that mean in terms of exponential? 3 to the 4th equals to 81. So that little motion here, you should get familiar with it, where you go this over here gets to that. It's pretty much how I do these in my head. I just sort of wrap my little thing around and get it. So if it helps me, it's got to help you guys. Well, not necessarily, I suppose. Okay. The next section is going to simply do the other thing. Can you take an exponential and turn it into a log button? A log problem. Okay, so we'll take number 5. We have 64 to the 1/2 equals to 8. How does the log equation look for this? Well, I'll write the log bar. What's the base?
64.
What's the inside here?
1/2.
8 equals to 1/2. So what I suggest you do here is now to check yourself, do that little curvy motion here and see is that exactly what you have written up there. And it is, right? Number 6. I have 12 squared, which doesn't equal 144, so I'll write log and you tell me what's the base? What goes in here?
144.
And what goes over here? Okay. Do that. You do enough of these and it just becomes repetition. Number 7. 9 to the -2 is equal to 1/81. So here's log, base what? Of 1/81 equals -2. That's 8. Okay, now let me just do the last one. Number 8. 1/12 raised to the second power equals to 1/144. That is a true statement, obviously, but we can change this. And what is the base? 1/12 of 141. This thing right here, 1/144 is equal to. That should be a negative, right? No, sorry.
No,
It's
it's true.
right. It's right. So that's just an exercise on trading from logarithms to exponential equations and from exponential equations back to logarithms. I want to, well, maybe we'll do a couple of these. I'll leave some of the next ones for you to do. Yeah, I will do that. We'll leave the 9 through 14 for you guys to do. Let's go down all the way to 21 and see if we can handle this. Okay, so now we're going to get into actually working these things out. It says there log base 4 of 64. Okay, most of you have a TI version of the 83 and 84, right? Most of you, some of you have an 89. Anybody have an 89? Okay, talk to me after class about how to do this on the 89. It's not going to actually happen today anyway, but you notice that there's a log button on there. You see it? It's right there below x squared. It sure would be nice if we could punch log base 4 of 64 right into the calculator to see what the value is. And I'm telling you, you will be able to do that. Except that this log button here is log base 10. And what is this log base? Okay, so the calculator only has 2 log bases on there, log base 10 and log base E, also known as the natural log. And the thing is, we're going to have to figure out a way to change bases before we can use this calculator. So we will get to that. In the meantime, we can still do this by hand.